Hello, guys. We started with assignment 2, problem 1, 2, and 3. I just started recording right now. Apologies. But I'll just try really quick, just for the sake of recording, but problem 3, because probably.
The thing is, she sent the notes, will be the same thing.
Uh,
Or you want
okay. I mean, I don't know how people like to learn, so I'll try my best to go as fast as I can.
do that?
Sorry, guys. All right. Q2, 3. Six, 7. The language for this problem is AB4 lower omega B2, where lower omega is AB star, where that means that lower omega can be any combination of A and B or lambda. And how we can simplify it is kind of like understand what we want to do is we set it on the paper exactly what's trying to say us. So this is restricted as exactly this many A's and B's. So what we can do in the machine is do the same thing, right? A, B, 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 B. Now for the lower omega, since we have any combinations between A and B and lambda, we're going to think it as that's where the loop is going to happen between this kind of like states. So first we make it to send from Q5 to Q7 two B's, and then we can make Q7 to kind of exactly just end there. But what if we want any combination between A and B or lambda, is by just sending A here, where think of Q5 as it's lower omega, where you can kind of like now loop around and choose different combinations of A and B. And since this is a DFA, we also can do the same thing for Q6 for A. And also remember that we need to send exactly as many transitions per state, depending on how many variables are in the alphabet. So for the other states, that was very restricted. We are sending the other variables to the trap. This is A, this A, A. This is B, and this is A. We also loop in B here. The reason we're looping B at final state is because let's say we only choose as many B's as we want, right? And no A's at all. We're still going to end with two B's in the end because of two transitions that is happening between Q5, Q6, and Q7. Yeah, I just went a little bit quick for this because we were working on it earlier, but I wanted to record it before going to the next problem. Problem 4 now. Problem 4 asks to find a DFA for the following languages on alphabet A, B. So we still have A, B as our alphabet with a language that lower omega will have its length. If we take the module of it of 3, will never be 0. That's what it's asking. So how can we do that is, well, first we kind of like help to construct it. I'll just go some examples that I wrote on my notes. Okay, let's say it doesn't matter what variables we choose, right? We can choose any A or B combination. But the module, when you're modulating by 3, kind of like it shouldn't be 0. So let's say, right, you do 1 by 3, that will not, the module of that will not be 0. So that's 2 would work. 3 by 1, it's 1, 0. So that this will not work. And we kind of like see this pattern where this works, 5 works, and then 6 will not work because it's equal to 0. So what we want is something that is not equal to 0. So how can we do that is also 0 mod 3 0. So that means that the initial state is going to be a final state. And now the second state is also going to be a final state because when you're taking the module of this just 1A, let's say, right, it will still work. It's still not equal to 0 if you take the module of it. And if you do Q2, again, it will not.
Can you explain why Q0 is an accepted state?
It shouldn't be because 0 mod 3 is 0.
Yeah.
Oh, it shouldn't be 0. Yeah, you're right. Okay, sorry. Yes. Yep, you're right. I was thinking as it is as it.
But why
it
should
is not
not?
a
That
0.
one was correct.
What was that?
Mod 3 shouldn't be 0.
Because 0 module 3 it's 0.
Oh.
Yes, it's not anything else. You know, it's 0, but we don't want 0. Yeah, sorry. You're right. Yep. And here, it is a final state because if we take the module of AA, it's not going to be 0. And what we can do is, since it's between A and B, we can choose any A and B. If we loop, I have a question, by the way. If we loop, right? If we loop, let's say B here and B here, we can choose as many B's as we want.
No, you should make from Q0 to Q1, you can pick A or B, it doesn't matter.
Okay,
Same
yes,
thing from
yes.
Q1 to Q2, you can pick A and B,
Yeah.
it doesn't matter. At Q2, have it loop back to Q0 with A or
Q0. So it
Yeah,
can,
that way-
it cannot, yes. Yeah, that was, I was gonna ask. So like, it will not be accepted because if we loop like we can loop 6 Bs and that will be the length of 6, which will not work. Or like if we put, I'm sorry, if we choose, let's say 5 Bs here, and we go to the next transition of, let's say we choose A, that means that this will be 6 B, 5 Bs and 1 A, which will have a length of 6, but 6 modulo 3 will equal to 0. So this is not correct. So it's not, in this problem, it's not a good idea to loop to states itself, because you can choose as many, the length as many as you want, and you can end up with a, if you take the modulo of that, you can end up with equal to 0. So you choose A and B, and A and B are the same here. And then here is A and B as well. So every time now, when you are going to the third state, to the first state, initial state, the length will always, if you take the modulo of that length, will always be 0. But since we don't have it as a final state, it will work for us for this machine. So yeah, basically, there it is. Any questions? I'll remove it. I'll erase it.
What if you loop both A and B? Well, no, then there's no connection.
Never
mind.
Yeah, that's what I thought that one. I have to check my other notes on my computer. I'm gonna start the recording. Okay. Problem 5. Problem 5. A run is a string. It's okay, I can read it. Okay. A run is a string. In a string is a substring of length at least 2, as long as possible and consistent entirely of the same symbol. For instance, the string ABB contains a run of B's of length 3 and a run of A's of length 2. Find DFAs for the following language on A. So again, the alphabet is A and B. And the language is, well, every run of A's has length either 2 or 3. So what is a run first? So it states in the homework, it's at least of 2. A string, substring of at least 2, as long as possible, it's consistent. So let's say AA is a string, AAA is a string, A is not a string. ABA, A it's not a string. EB is a string, but we need with A's with at least. It's either every run of A's has a length either of 2 or 3. That's all we need. Sake, guys. Sorry. Maybe it'll have. I just called it like that, but doesn't have to. Yeah. Also, now that I was reminded, if there is nothing, if it's zero, it's still a length as well, because it hasn't started it, basically. It's a run, sorry, it's a run because it hasn't started it technically. So that for that reason, Q of 0 is the final state. So now we need A. A again. We're trying to make the run for 2 or 3. A again. So, okay, 3 we know is going to be a final state. Q2, again, we know that it's going to be a final state. Q1, the reason Q1 is a final state as well is because we haven't started to make it a run. So it won't count for it. Because we can either choose to have the run or not.
But wouldn't that make it there's an option for it to stop at just like 1A?
But we haven't even started the run, right?
Okay,
So think of it as like this, right? It will still be like a run because we have 2 A's here, but we haven't started 1A here. We haven't started the run here. I asked the professor about it. It's a little bit confusing. And think of it as the run has to be bigger. Well, it has to be the run. We need 2 runs or 3 runs. But also, if it's not a run at all, we call it as, if we haven't started it, we're going to call it as a final state because we haven't started the run yet, right? And we can choose B's.
I'm sorry, isn't a run how many A's you're allowed to have at one time? So shouldn't Q1 and Q0 not be accepted? Because for Q1, you have a run of a single A, and for Q0, you have 0 A's.
But you may not
1A
have.
is not a run though.
Yes,
Neither
when A
is
is not
0.
a run.
Yeah, but if you go A, B, then that's considered a run of 1A.
No, it's not because
No,
1
because-
isn't a run,
One, you need
Isn't
the
a run
exact.
that how many A's are in a single time?
but it has to be at least 2 before it's
Yeah,
considered a
it's
run.
a little bit confusing.
Yeah, so then why would Q1 be accepted then? If you need at least 2 for it to be a run.
A run, yes, but we also like don't need a run at all, right? So we
Yeah,
can choose.
it'll accept
A.
nothing.
So we don't accept anything. So it's Q1. It's a final state for that reason. It's very confusing. I literally spent kind of many hours to understand what professor said for this, but think of it as since we haven't started it at all, right? We haven't started to initialize this run. We can end it, right? We don't have to start the run. But if we want to, we can consist of 2 A's at Q2 and then 3 A's at Q3.
I see. Thank you.
And we want to loop. Well, let's say, for example, if there is no run, right? Or if there is a run, we need to include B's to the initial state. If you want to like start another loop and then end up with 2 A's or 3 A's. Right, but if we want like to have more B's in our machine or whatever, we need to loop them back to the initial state because if we decide to have a run of 2 A's or 3 A's, we can go from here instead of like looping back here, and this will not work, right? Because it'll just break the run. And then you will not have any options to choose to have a run at all. Same goes for 3.
How, since this still has an option to continue forward, even if it's a loop.
So let's say, right, you break the run, right? You wanna have as many B's as you want, right? So you break the run from 2 A's, you break the run. you choose B's, you choose as many B's as you want, and then you go back to choose the run again, right? So now you can have the option to end it there with 2 A's. Or if you want to, it goes the same thing with 3 A's as well.
But the loop, how would that be correct?
If it's not right, if you,
Yeah, how? Why would it like explain?
because it will break the, you will not have any options to have 3 A's anymore. As a
Oh,
run,
you only have like more than, you have like.
you
four?
only 2 A's. No, you only have 2 A's as a run, but you will not have the option to make.
How come? Did you know you're not able to continue forward?
Yes, exactly. You'll just break the run here.
It's because it's a.
Well, you have the option. So when you're making the loop, you're making the option to choose B's, right?
Yeah,
So now if there are going to be many like combinations, right? But you're going to have this combination that is going to break this run. And we don't want any combination in this machine that will break our run for 2 A's or 3 A's.
so it's breaking it because it's creating more combinations.
Breaking is creating more combinations.
That's what it's breaking.
Well, it is creating more combinations because you're adding
Another.
B's in
Yeah.
these rounds of A's, right?
That's what you mean by like breaking it, because it's just creating new combinations that they're like kind of.
They are not in what we want, right?
Yeah,
Yes.
okay, gotcha.
I don't think you need the loop of B at Q2 though.
Yes, we don't need
Oh,
it.
okay, you don't need
Yeah,
it.
yeah, that's
okay.
why we're.
Oh,
trying-
I must have missed it if you said that, sorry.
And then for you need to send the trap to. You need to send A to trap from Q3 as well. Any questions for this problem?
Q1 doesn't need a trap, B to.
Yeah, because it's like self-looping here.
Okay, because I have it where Q0 is also self-looping, but Q1 is not a final state and it goes to trap, the B. And then the trap is looping itself again with A and B.
The trap is loop. Oh yeah, A and B. Sorry, yes. We need also A and B here. So sending here, right? QA to trap. I think that would be allowable as well, right?
Since mine is, Q1 is not a final state and it doesn't loop back to Q0, it just goes directly to the trap. And it's.
This one goes directly to trap, you're saying.
Yeah.
So
And the-
this. I think that will work as well, right?
I don't know if the grader got tired, of just gave everybody 100%.
Yeah, I'm not sure about
It's-
that.
I don't
It's kind of scary, but well, let's try to figure out, right? There is what I'm thinking right now is I don't think sending B here or the trap will make,
Difference
well, it will make because
in terms of the right answer. I'm talking-
it'll not give a combination, let's say A, B, well, it will give A, B, A. Yeah, it will not give a combination of A, B if we send B to trap, right? That's what I was thinking, like, okay, we need to have as many combinations as we want while maintaining the restrictions that is given to us. And to add for the Q0 and Q1 being final state is because, again, we haven't started a run yet. So that's why it's a final state.
This is what you got?
That's what I actually got.
Did everybody get like 100% on the thing?
Did anyone
I
get?
did, but I did not do this. Like, I think if this is the right answer, then I 100% got number 5 incorrect, but still got 100.
I got 100.
I
too. I think you just got tired and just give everybody 100.
This is a little bit concerning.
It is 100%.
Well, let's try to figure out, right? We're like, how many people are we can try to figure this out. 1, 2, 3, 4, 5, 6. We're 6 people.
I get why you said like the Q1 is a final state since and it has an initial.
Well, okay, I had hard like understanding this. The reason is because we're not starting a run at all, right? What could be a not final state is if you have, let's say this A, right? We're not sent to the trap, let's say. I don't know, for some reason, right? You create another final, you create another state. and you're pointing to A. So it will not end there because we don't want any rounds with A, but still it will be wrong because we need exactly like either 2 or 3 rounds of A's, right? But this will not be, think of it as, this will not be a final state because it's asking 3 A's or 2 A's, or like it will be a run if even it doesn't start. That's something like that, he said.
So like, this won't even be a part of it because it'll have 4 A's, right?
Yes, but I'm trying to kind of like give an idea of what will make a run that will not end to a final state, which is this,
Wait, how
but
many,
not this.
how many inputs of B are required, or it doesn't say,
How many inputs
of B,
of beat
or B,
or B
of B?
OP are required? As many as you want. So like it's not, since it's not giving you any restriction of B's, if how I approach this is trying to make any combinations possible for B's between like what is asking me of having two rounds of either equal to rounds with length equal to 2 or 3. 2 or 3.
The only thing I'm saying is, since B is not required, it's not stated, and we should have as many as we want. That's why I put the B to the trap, and just, I don't want to move it back to Q0.
But if you want as many B's as as you want, right? Why would you send it to a trap? You will not
That's
give
what
the
I'm saying, too.
possibility to.
I mean, since you only have, you have a loop, because you have a loop, which creates infinite amount of B's anyways, that's what I was saying.
But it will only create infinite amount of B's on the left side of the.
For the table.
So let's. Oh, they're
I
not.
mean, Q1 will also be on the left side. You know,
Let's say what was that?
Q1 is also on the left side. Doesn't really matter.
Yeah, you're right. Well, you
Maybe
want to
I'm-
have. Yeah.
Oh, go ahead. Maybe I missed it, but why is there a forward B off Q1?
Here.
Yeah.
So
That was my answer, how I put
Oh,
Q1.
okay.
I put Q1 as not a final state and sending B to a trap.
So the reason, well,
I see.
think of it this way, right? If you don't want a run, right, of if you want this, if you want A, B, 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 and then A, right? How are you going to go with your machine? How are you going to go with this combination? I don't know if you guys see it. Oh, let me write it here. Sorry. Use blue. A, B, 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 A. With respect with your machine, right? How would you write A, B, B, A? How will your machine process it? Let's say, right? A,
And
and you send B to trap, so it will not work.
Yeah.
But with A, B, 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 A, right? And you have 2 A's rounds.
I mean, it's one combination. There could be another combination, and then that's why I see it. Or you're also thinking like if you have a B right after the A.
Yes. So you're trying to,
Because that creates more combination, since if you have it to trap, if you have B to trap, you're locked to having 2 A's that need to be there. Since
So you-
with my method, you're only locked to having A, and then you can have a B, because Q2 goes back to B.
but the run of A's can be in the middle between B's, right?
Yeah, that's what I'm saying. With mine, there's a limitation, because you're forced to having 2 A's there.
Yes. So
Well, then
it's not including all combinations of how this language can be correct. Like it needs to include all the combinations that this language is requiring you to. It's kind of like, think of it, like when professor said that language of like A, B, like it says that all combinations between A and B and lambda, right? So, and with these two, it's kind of like similar. You're trying to understand all the combinations that you have with a run of 2 A's or 3 A's, with B's included everywhere, right?
Now, my only thing would say is, it depends on how he wants it, because this way is like, this is like, I guess, the most, absolute way, because you're reaching all possibilities. But in the other way, it's kind of like, it's reaching possibilities, but not as much. So I think it's like how precise you want, you know? You know what I'm saying?
Yes, I understand what you're saying.
I don't know, like, cause I don't know if because he seems pretty chill. I remember in class saying, like, don't think of it too much like that.
Yeah, you're right.
So that's why I think she both graded us right, because we had like, we have also have like many possibilities, but not as much as you do.
I understand.
Now, if the question, if the
Oh,
language is
sorry.
different, if the language was different, right? So like something more precise, then maybe, yeah, you know?
Wait, or do something wrong.
No, you still, you just put the chat A, that's it.
Oh, yeah, A.
Mm. I guess make it more visible.
Yeah, all right.
I guess we're both right, I guess, I don't know. Only thing is, I don't know why, because how much would it change if it's Q1 is out of final state and it just goes to chart? I mean, like basically how I said it, you know? Well, can it be Q1 being a final state and going to the chart? Is that possible?
What would you send in the chat? Yes, I guess because you can, you're not including, well, if you, let's think, okay, what I'm thinking is, if you have in the final state, you don't have to send it to the chat, right? You just end it right there without any bees being
is-
processed.
Yeah. Well, I guess it's just like the way you perceive it, I guess that's what he's gonna grade it at.
Yeah, now I'm lost too. Do you guys have any thoughts on this?
I saw a couple of examples online and they match what you currently have. I'll send a picture, but it's the same exact thing you have written. Like the problem is the same and it's exactly matching what you have right now. But yeah, you did it exactly how they did it. So I think that's the best way then to go about it. I think the TA just graded us all correctly.
Yeah, it could be what Andrew said. It's because they may be all correct, but depends how many combinations you are including in the
Yeah.
machine.
Because we both have multiple combinations, there's just one is more specific, has more combination. Which I guess technically both right. But one-
Yeah, it depends on like, yeah, or not just optimal, but like depends of what you want to use it for. What I'm thinking is like, let's say a door, right? When it locks or like when it unlocks, and it's probably like, let's say A and B are, if we have a person inside the house or not inside the house, will it lock automatically? Or if you have a blackout, will it lock or unlock? Kind of like that's the thing in combinations, and we are choosing the door to act differently.
Yeah,
For what purpose we need it. That's what I think.
exactly.
That's why they're both correct.
Oof.
I guess I'll go to homework 3.
Thank you. Last time we did only homework 3, question 4 or question 5. Should be good for homework 3.
We did the last homework for question.
Question, so homework 3, we did only question 5, the last question.
Yeah, we did the last question for homework. No, we didn't do homework 3 any questions actually.
No, we did.
Did we? Let me check.
No, we didn't, we didn't.
Yeah, we did the last thing on
We did,
in our
GTG.
notes. Yeah, we did
We
GTG.
didn't do any homework yesterday.
It was Friday.
Yeah, Friday, yeah.
So problem 1 of homework 3. We are on homework 3 right now. It's
You guys-
3:41.
15 minutes ago.
Yeah, got a little bit of time.
Put a minute on that question.
Yeah, we spent a little bit of time on that.
We should go over linears a little bit.
On what?
Right and left linear.
Oh yeah, linears. Yeah, like
yeah,
right.
right.
Yes. Gotta go on that as well. So I guess we will rush a bit on homework 3. So okay, it says let L1 be the language accepted by the NFA below. Homework 3, problem 1.
You wanna hold my number? Well,
Okay, I'll try to like solve it without looking at the
oh,
notes.
okay, gotcha. like that.
So let's build the NFA, right? Or since we guys have it like in our screens, but I'll just go over like making a table for it, right? So let's say Q0. Let's take the states first. Q0, Q1, Q3. Q5. You have A and B's. So A is pointing to Q1, from Q0 to Q1, but as well as Q4. And then no B at all. You don't actually have to build this kind of table, but kind of like to understand what the language will be, because lower it says find an NFA that accepts the language L equal to L1 union A5, right? Q1 is it's AA, it's Q2, Q3 it's from Q2 to Q3 it's A as well, it's pointing A. There's no B's at all. So this alphabet is just going to be all straight A's. I thought there was a B. Q1, Q2, Q4, 5. Okay. So from Q3, there's nothing, pointing nothing. And then from Q0 is pointing Q4, Q4 it's pointing at Q5, and then Q5 is pointing at Q4, so it's kind of like a loop. So how we can build this L1 language, right? Language 1. What we can do is, since Q0 gives like two different choices, we kind of like can make two unions out of it. So the first one is going to be AAA, so it's going to be A3. Union. Well, let's see what the next one is. So okay, it goes A, and then it does another A. So that's even, right? Even A's. So it'll be AA. But then if it goes to the next one, it will become 3 A's. But Q4 is not a final state. Q5 it's a final state. That means what it's telling us is that if you choose the other option, you will need an even number of A's. So how we can write that is by doing A2N, just like the first problem or the second problem from homework 2N, where N is bigger than 0. And now we can construct L, where L is L1 union A5, which will be equal to A3 union A2N, where N is bigger than 0, union A5. I'll remove this and just leave the language on top. I'll just write the language on top now. So we need an NFA, right? We don't have to like worry much with it. It's going to have less restrictions, kind of like how we play around with it, rather than DFA. So let's start with well, let's try to find a pattern, right? So here it's giving two ORs, right? So we don't actually have to give like another OR to our to our machine. But what I mean by OR is giving 3 choices of transitionings. We don't need this because kind of like if we find a pattern, right? A3 and A5, we can kind of merge them together, pointing to like different states and achieve the same results as we would have had with three A's here and 5 A's here. Kind of like merge them together and just make a straight line. Patterns really help in building these NFAs. So let's go with A first. A pointing to Q1, and then pointing another A to Q2, and pointing another A to Q3. Q3, since one of our restrictions is that one of our choices is that it's going to end up with 3 A's, then we can set Q3 as the final state. And then it's going to happen the same thing with 5 A's, where we can end up with 5 A's, Q5. So far, so good. And then we don't need any changes for the lower options. Oh, I call them lower because like how I constructed the NFA, sorry, not DFA, NFA. Q6, it's not going to be a final state because it's just 1A and it's odd. We kind of like this loop where we need even number of A's. So Q7 is going to be a final state, 2 A's, 3 A's not final state, 4 A's final state, and so on and so on. This is problem 1.
How did you come to the conclusion for A to N up there, like initially?
Oh yeah,
Yeah.
so think of this, right? Look at or the problem, the canvas.
Yeah.
Is the same drawing. So think of it, right? You have 1A, you start from Q0, you point at Q6, you have 1A. And then you have at Q7 pointing A again, though which Q7 is a final state, which you can choose, you will have this option that you can choose the minimum, you can choose 2 A's, or you see how A's goes to like Q6 and Q6 is not the final state? Think of it as, all right, 2 A's or 1A, let's say, right? 1A going to from Q0 to Q6 is going to have, it's not going to be correct, right? Because, well, it's not going to be correct. It's just not going to stop there because Q6 is a not final state. But then given another A, we'll point to final state, which kind of like we will see a pattern if we still give A's to the machine, right? Give more transitions. If we give another A, that will be to 3 A's, which will end up to Q6. And then if we give another A, it will be.
I see, yeah.
Yes.
Okay.
So how this 2N, how I ended up with the 2N, if you think, right, I said if N has to be bigger than 0. Because if we do 2 times 0, it's going to be A of 0, which is going to be 1. So it's going to be 1A, right? But 1A is just odd. So it's just pointing to Q6, so that's not correct. But if we choose 1, if we set N is equal to 1, it's just going to straight up just send you to 2 A's, and that will be a final state.
Yeah, and it'll always be even. Okay.
Yes.
Yeah.
I got you. Thank you. You're still thing?
Are you still done?
Any more questions? Yeah, it's gonna have the same. So now we need to find for LM, well, L star. I can.
Okay.
I got it.
Okay.
Yep. So now, this is kind of like L star is, think of it as, it's making you to transition all the final states, kind of like combine all of these final states into one, like just straight up just one final state, which will work, right? I'll say that as QF. So instead of just having these multiple final states, we kind of like have this just this one where we can use lambda transitions, this free flow that will send all of these combinations to the final state without having these final states, like 3 final states basically. That's what's kind of like is happening with the L star, which means any combination of this, including lambda. So like we don't even have to choose one, right? So how we can start this is, of course, by a lambda transition, starting from Qi. This is a lambda transition. And then if we go to 3A's, right, we can end it here, but the language says that we need a lambda as well, lambda transition. And it's going to be much easier for us to include this final state, kind of like take the role of these other final states, basically. So what we can do is kind of make this free flow for these other final states. So if we have 5A's, it'll just end up to the final state. If we have 3A's, it will again end up to the final state. The reason it started to form like this is because we included L star now. Why would we need this kind of approaches in real life situations, like in real, like if we want to form real life systems? I'm not sure. I have to do more researches about it. But just by viewing it, and then we know that lambda. Oh, also we know that lambda is like free flow. So that will like help us understand why is this happening, like why are we sending lambda here to the final state. And if we just want to include lambda, just lambda, straight up lambda as well, we can actually point from Qi all the way here. But if we want to, let's say, what have I forgotten here? Oh yeah, final state with Qi. Why that? I have to think a bit about it. So why we're pointing at the? Oh, sorry. Why are we pointing? Why are we pointing final state lambda at Qi? Think of it like this, right? What if you still want to include something, right? All right, you made the choice to go from here to final state with lambda, but now what if you want to start some, right? Now you go back to the Qi state and then start doing whatever you want to do, either 3A's, 5A's, or even number of A's. Does that make sense? Any questions? All right, I'll go to the next one. We are at problem 4 or 3. Problem 3 is asking, find an NFA without lambda transition, any lambda transitions, and with a single final state that accepts the set A union Bn where n is equal or bigger than 2. All right. So let's build our language first. L where A union Bn where n is bigger or equal than 2. Okay. So first thing that comes in mind is 1 or, right? So we can kind of like separate them and choose. Let's start with Q0. We don't need it. We're not supposed to have any lambda transitions, by the way. It's still an NFA. It's a non-deterministic finite automata. With 1A, we say that, yes, this is allowable. This combination is allowable. But we can also add another state, Q2, that will help us construct this other part, which is B, where B can be equal, can be equal to 2 or more than 2, right? So what we can do is, okay, 1B, 2B, yes, correct. And we can also do 1B, as many B as we want, or we don't even have to include it at all. Without any lambda transition, we're not using any lambda. This kind of like represents the lambda that we're given a restriction not to use it, if it makes sense. And then we can just end it with a Q1, with a B, with another B at Q1. This one was pretty straightforward. And the other ones a little bit. So yeah, let's try to verify if this is correct, right? Right, 1A, correct, right? We don't have any other transitions. We don't have to like include anything or a trap for A's and B's that A and B transitions that come from Q1 because it's an NFA. We don't even have to include that. So B, right? B of n. We just need, first we need 2 B's. So you have 1B, 2B. That's correct. And then B. You can have as many B's as you want here. And then you still end up with a B, which will have like, well, n will be just this amount, which is bigger or equal than that. Which is equal to that, actually. It's bigger than 2. Yeah. Any questions? Okay, I will go to problem 4. Yes, we did went over problem 4 now that I remember. For Q0 being or not being the final state. Which yeah, I have the question. I'm probably like
On Friday?
yes, remember we were asking about if Q0 is a final state or not.
Oh, yeah, well, I keep confusing with Q5, but remember Q5, we did it with the professor in class.
Yes, we did. Yes, yes, we did. What is the time?
401,
4:01. All right, we got like 30 minutes.
29.
39. So convert the NFA defined by the followings with initial state Q0 and final state Q2 into an equivalent of DFA, equivalent DFA. All right, so let's do this. Q0 A. Right. Q0 is pointing to Q1, Q0 with transition of A. Then Q1 is pointing B transition to Q1 and Q2. And Q2 state is pointing A transition to Q2 itself. And Q0 lambda at Q2. So let's build the table for the NFA. How I like doing this is also include lambda in it. I know that professor did not, but it's kind of like, it helps you more visualize it. So Q0 to A is pointing Q1. Q0, Q1. Okay, Q0. Just wanted to make sure if I wrote it correct. All right, Q0, Q1. Nothing B, but it's pointing lambda. I mean, it's doing a lambda transition itself. Or no, at Q2. So Q2. And Q1 doesn't have anything at A. At B has a Q1, Q2. And you're not. And Q2, it's pointing a transition to itself. And well, so far, this may not be exactly correct, but when I draw the table, we're gonna fix this more. Okay, so let's build the table. This is basically the same, but it's kind of like more, kind of like visualizing more here. So Q0, also we have to include that Q0 is start, Q2 is end. Okay, Q0, A, transition to itself, and the Q1. Q1, it's transitioning B to itself, and Q2, which Q2 makes it a final state. So this is a final state. Q2, it's pointing A to itself, and Q0 is pointing lambda. So since Q0, it's having a free flow to Q2, this doesn't exactly look correct because of the free flow of lambda. So what we can have is, we can also have I think B included it. So B is going to have pointing nothing. Well, Q2 is going to have pointing nothing at B, but Q0 is going to have a, I think a B pointing to Q2. Let me see. Looking at the notes for the moment.
Are you talking about in the table?
Yes, the table.
Yeah,
Q2 because of the free flow, right?
right. But so will A.
Oh yeah, Q0, Q1, Q2. But when we do the DFA, that will turn into, yes. Sorry. Because of the A here, free flowing to Q2. Any questions so far?
Under the lambda column, how did you know to put Q2 there?
Oh, because it's saying right here. Q0 lambda Q2.
Oh, I see. Okay, okay.
Yeah.
Thank you.
All right, so now let's try to build the DFA. I'll build it. I'll remove this since we have this, and continue the DFA table with this one. We have QZ. Oh, first DFA A and B states. I put it. I don't want to leave it empty here sometimes, so I just put S for states. So Q0 Q0, it's pointing. Now it's pointing to Q. Because since this is okay, yes, this is going to go there. So as well this. I was just transitioning the first diagram to here. That's why I was kind of confused. But the Q2 at B, it's going on the DFA is going to point at B because of the free flow. And A from Q0 is going to be Q0, Q1, Q2 again. The reason because of the Q1, because of the Q2 is because of the free flow for the lambda transitions. So we add here Q0, Q1, Q2, and then at B we add Q2. Now we drop this state, since we formed this new state, we drop it here, right? Q0, Q1, Q2. And then we look at the table over here. We look at, for A, right? We look at Q1, Q0, Q1, Q2. What, for A, right? What includes, what does it include? It includes Q0, Q1, Q2. So we write it for the A transition. It's going to point to itself. It's going to transition to itself state. And for B, Q0, Q1, Q2. Oh, sorry. We have we don't have anything pointing from Q0 to B nor from Q2, right? But we also we from Q1 we have Q1, Q2. So pointing to itself and to Q2. So that's what we get for the P transition for Q0, Q1, Q2, which is Q1, Q2. Now we get this state, since we got this new state formed. We drop it down, and we look at Q1 and Q2 from the NFA table. We look for the A transition, right? For the A transition, we see that only Q2 is connected. So we write Q2 at the A transition of the DFA table. And then we look at B for Q1, Q2. We have Q1, Q2. So we do Q1, Q2. Then we drop Q2, which is pointing. It's pointing A to itself. But then we see that there is a phi. There is a empty transition here, which for DFA it will not work if we don't include B to it. We don't use B at all, because the DFA, what the DFA says that for each state per transition, like for the alphabet, we need as many transitions as the alphabet has variables. So if the alphabet has A and B's, we need to include A's and B's for each state of in the DFA. So here, what we're going to do for the B transition for Q2 state, we can just send it to the trap, to a trap state. I usually write it Q0, but if it helps more for visualizations to write it as a T, that stands for trap, you can do that as well. So, but we also should not forget that T is a state as well. So we drop it, and it's a new state. So we drop it down here, and what we need to do for the trap is obvious, pointing A and B transition to itself. That's what the trap is for. So let's build this. We don't need the NFA anymore. NFA table. We got what we wanted. I'm going to keep this one, or You guys need it, or should I just erase it? For
You
visualization?
can erase it.
Okay. I erase it. So now we start building. Oh, yeah, also one more thing is, since Q2 is the final state, all the new states that were created by construction, the DFA table, are going to be all the new states that include the state Q2 are going to be final states on the DFA table. So I'm just going to circle them to kind of like know which one is going to be a final state, and proceed of building it, or constructing it. So we have Q0, the initial state, transitioning variable A to Q0, Q1, Q2, which is the final state, double circle. And I'll leave Q2 for now, and B transitions. I'll go for the A's. Then let's go to Q0, Q1, Q2, transitioning A to itself. And okay, we see that we have Q1 now. We're going to build that as well, or construct that as well. It's a final state, so we need 2 circles for it. And we see that it's pointing A, or it's transitioning A to the next state, which is going to be Q2. And the Q2 is pointing, or it's transitioning A to itself. And let's do the B's now. Q0, transitioning B to Q2. Q0, Q1, Q2, transitioning B to Q1, Q2. Q1, Q2, transitioning B to itself. And Q2 transitioning B to a trap, which will include A and B transition to the trap. This is the answer for problem 4, I believe. I was thinking, well, while I was doing this problem, I was thinking we were discussing it the last meeting, is what if Q0 is the final state, or can the Q0 be a final state for this problem? Because, well, it has a lambda transition, right? And it kind of works as a free flow where it's going to be the same state as the other state that it's pointing to, which is Q2, which is a final state, right? And it's kind of like gives like these few hints that, okay, we see that this final state, right? It has 0 included and 2 included as well, and it's a final state as well. So I ended up, it may not be correct, because as I said, like these hints, right? They kind of like make that bridge of, instead of including Q0 as a final state, we make this bridge of Q0, Q1, Q2 to kind of work at the final state to finish the job for the DFA that we want, basically. So I don't know. I'm not sure. I have to study more about automatas, but I'm gonna look if Q0 it's a.
Can I ask a question?
Yeah.
So because like you're saying, if Q0 is an accepted state, because in the original you can get lambda and then automatically be transported to a accepted state, shouldn't that make then Q0 accepted?
Yes, that's what, like, the whole point for our last meeting. We had like a 30 or 40-minute discussion for that. So
because I don't think I did it correctly, but for mine, I have the initial one as Q02.
Can you explain that again? Can you?
Okay, so I'm gonna send it. I also talked about it a lot with another person in class, and I couldn't understand it. But the way I have mine set up is, instead of it starting off at Q0, it starts off at Q02, Q0, Q2. I'm gonna send a picture. It'll make maybe.
Can also see how you build the DFA's tables, DFA and
Yeah,
NFA
yeah.
table. What is the time? 17. What was
Give
it?
it a second, it's loading.
Oh, okay. Yeah, no problem.
Okay, the way I have mine accepted is because it starts off at Q0, Q2, that it's considered an accepted state. But I don't know if I built mine correctly.
Okay, so the NFA, Q0, Q1, yeah, and then Q0, Q2. So, so kind of like that's what I'm doing for Q0, right? I'm kind of, I think Q0 and Q0, Q2, it's the same in the same like how we constructed it. We're just naming it differently, but let me see why you named it differently for the DFA.
I did it because I followed along this video. So I was watching this video and that's how this lady did it. So I kind of just did what she did. But she doesn't answer the same question. She answers a different question.
I see.
I don't know if it's right because again, someone said that the professor said something about starting off at a lambda state, but I didn't understand that.
Did she work with equivalences? So did she started doing the stating the equivalences out? So for example, I'm going to remove the DFA, by the way, so I can just write there.
So if you like skip to where she like around 6 minutes into the video, she converts an NFA to a DFA. That's where I started watching her video from. She has like a list of rules also on the corner that explains some stuff. But again, I don't know if this is right or incorrect, and they haven't graded it, so I have no way of knowing.
Yeah, that's a bummer too. They should have graded it so we can kind of like know what we did wrong or correct. But yes, so she's working like with the equivalences. So she's not stating them how our professor does, but it kind of works like this. A second. Kind of work like this. Remember how you started with the zero equivalence, and then you set all the non-final states from the left and the final state from the right. So you do Q0, Q1 on the left state, and then or the left set, sorry, and Q2 at the right set. And then you check, right? You do this first equivalence. Yeah. And you look at the NFA pointing at Q0, transitioning Q0 from Q0 to Q2 with a lambda. That means that Q2. This is for minimization, but kind of like it helps understand as well, like how the new states are formed. But if we have Q0 and Q2 for the first equivalent and leaving Q1 alone, but also Q1 points at the final state, so that will be included as well here. If we build the table again and check the different transitions between A and B, they will be the same. Or they'll be the same. So I guess it's the same thing. Q0 and Q0, Q2. it's the same thing. Let
It
me,
does seem like he probably forgot to mention like if there's a lambda transition from Q0, how we would handle that. Because like we didn't do one like that in class,
yeah,
but it does make sense that Q0 would be a final state. But like based on what he showed us in class, it like you'd have to like imply that it would be, or like, you know, you'd have to just guess that it would be from the question, you know.
yeah.
I don't know if it gets marked wrong, I'm gonna say we didn't go over that in class. Because like all he said in class about final states was if the final state from the first, like from the NFA is like included in one of the nodes in the DFA, then it's a final state in the DFA.
Yeah. But also he mentioned something, I wrote it down. Let me see.
Yeah, I'm gonna see if I can talk to him before the test.
Is it possible to share his answer, his reply?
Oh, he didn't reply to me.
No, if he replies.
Oh yeah.
Thank you.
I just meant like in
Stuff
class
is okay.
tomorrow, like I'm gonna see if I can catch
No,
him.
okay.
Oh, he didn't reply to Parker yet?
No, he did not.
Of course.
No.
There is no.
You guys, it's the weekend.
Yeah.
I have written here somewhere that says that if there is a lambda transition, those two states are the same.
He said also in the discussion for the midterm, a correction for one of the problems he did in class. And that one doesn't start off with a lambda, but it has lambda transitions in it.
Oh yeah. Let me go with which one you're referring. Yeah, it doesn't have a lambda. Oh, it does have a lambda from Q1 to Q2, yeah. But it doesn't have a lambda from Q0 to Q2. I believe you are referring to that, right? From with zeros and one
Yeah,
transition.
so that's the only example we have where it has lambda.
I mean, we can try to add some combinations, and figure out like figure out from the NFA, do some combinations from that NFA, and then see if this new state that we did is like this new DFA does the same thing that the NFA does basically. And trying to figure out, I'm looking at my notes through the computer screen. Let's say I'm going to build a small NFA. Is this problem 4 or 5? Oh, this is problem 4. We can go to problem 5 if you guys want, or you guys still like kind of understand problem 4. Whatever you guys want. But let's say Q0.
Are we still recording?
Yes, I am recording.
No, are we still? Maybe you should make sure there's no
Yeah.
issues. Yeah, we are. 2 hours to make.
Honestly, I feel like Q5, question 5 was easier than Q4. Question 4.
Yeah, I know, right? It's pretty interesting. Okay. So we can have combinations of in Q0, right? Or in NFA, we can have combinations of A. We always need A, right? Always need A. Always need A. Okay. So that works for the DFA as well. So if we try to choose A, we will always choose A. But that's probably the reason why we cannot send B there and end up with the final state. Or no, that's not. I mean, yeah, that could be it, right? Why we shouldn't point B to Q2 first. I was realizing that. Should we point B to the trap because the NFA, what NFA is doing? Oh, it's what the NFA is doing is that it's saying for the lambda transition. Yeah, I'm a little bit confused.
For question 4, I didn't have a for 4. I didn't have a trap. There's 5 or 4.
This is 4.
Oh, yeah, I didn't have a trap for it.
I think you need a trap to send B somewhere from Q2.
I don't know. Remember talking to the president about this one.
We should have talked to him about this instead of 5 that day. But okay, Parker, I have a question. So why are you saying that with the lambda transition, right? Q0 can send B to Q2.
Because that's what he said in class, but also it seems like that's not the case based on his update here. He misspoke in class. That's what the correction's showing on Canvas,
What I had before was
which kind of sucks because I've been doing it that way.
Yeah, right. Because you train your brain to understand it that way, so now it doesn't.
Yeah, and then he sends an update 1 day before the final.
Okay, but let's try to figure out, right, why it's not that way. So if we're trying to figure out from NFA to DFA, right, we're sending just A to Q1, and we have no other way of obtaining B with this lambda transition from Q0 or to Q0, because the only B that we are having is from from Q1 pointing to itself and to Q2. So we have no way of retrieving this this B to Q0 unless we had like something for example, like another lambda pointing to Q0 or like a transition for a free flow transition, right? So we're not kind of like restricted to always start with A. So that's why this would point to a trap, because we're trying to have the same structure, right? We're trying to have the same structure, just like the NFA does, but for the DFA as well.
I guess I have the same thing, just the trap, I just named it Q3.
Yes, Q3 is a trap too. You can name it whatever you want it.
Oh, just correct.
Yeah.
Oh, 0.
No, just like, so I can say it, I want to say it again. T, you can put whatever you want in either of the states. You can name them whatever you want. The reason we're naming like this is so it's easier to track what we're doing and why we're doing it.
Yeah.
But okay, let's start. Okay, we figured out A, right? And B, why B is sending to a trap. But we need A to send it to Q2 because the lambda transition. So we are sending it to Q2, right? Because this is the final state that we can enter right there. All right, so that's done. So now we have Q1 pointing to itself and B pointing to itself as well, right? But since we need this each so how are we going to figure out like choosing as many B's as we want, right, for the final transition? Is Okay, that's, yes, how can we do that, right? This B, sorry, not this B, this B. How can we do that? As just by creating another state, which is going to be final with as many B's as we want to choose, right? And then we kind of get that answer for Q2 pointing as many A's as we want as a final state. And then we don't have any B's pointing anywhere from Q2, so we send that to the trap. The thing is though, is Q0 a final state yet or not?
That was the one of the big ones we had yesterday.
Do you guys, by the way, do you guys agree for Q0 to the trap sending B? You guys agree?
Yeah, I would agree.
Okay,
Too.
okay.
I'm not sure about the Q0. That's the only thing.
Yes, that's the only thing that kind of like,
I don't know if it's a point like where we can both be correct or something like that, like the other one.
well,
I think maybe be like we're just overthinking it too, because she says don't overthink.
it should be lambda. It should be final state because if you're not sending anything, you just want to end it, right? You just want to end it. You don't want to do anything, right? So this is what this is what this final state. This is like what lambda does, I guess. Like not doing anything and still sending it to Q2. Right?
Yes.
But if you want to still continue with doing A's, right? As many A's as you want. So you have,
Yeah, so that'd be true through.
so that's why this, I believe this is a final state. I don't know, but
Doozy.
I believe it's a final state. As far as I'm like trying to figure out. But I'll move to problem 5 now. So do you guys still wanna continue or wanna figure out another answer for problem 4? Okay, I'll continue to problem 5. I'll wait a little bit because sometimes when I'm in class, like in Zoom classes, sometimes it just takes me sometimes to turn off the mic and say something
Yeah.
just because I'm doing something else, like writing or doing something. So that's why I wait a bit. But okay, let's go problem 5. Problem 5. Problem 5 says, consider the DFA. So we are dealing with the DFA now, right? And we want to minimize it. We know that Q0 is a start and Q2 is an end. It's a final state. And we have the following transitions. From Q0, you transition in A to Q2. I need more space. I'm just gonna write it smaller. Q0, A, Q2, and then Q0, B to Q2. Q1, A to Q2, and then Q1, B to Q2. Q2, A to Q3, and Q2, B to Q3. Q3, A to Q3, and Q3, B to Q1, and B to Q1. Okay, this is Q1, by the way. Q2, Q3, Q1. Right. So let's, what I would say is, you can start with the equivalent. and be done much faster, but I like constructing first the DFA and minimize it from there. It's much simpler to visualize it, but remember this DFA sometimes can get more complex and it'll get more difficult, and it's not the best to just construct DFA and then minimize it, but also it's a good combination of doing both equivalent and construction. It will just take a little bit more time. I don't know how. I don't know what advice I can give for like the midterm because the time is limited. So, but let's try to build the DFA first. It's much better here, like when you're trying to explain it, but I cannot give a definite answer for them in a midterm. How will you go to it? But Q0 pointing A and B to Q2. Okay, so let me put them in order first. 0, Q1, Q2. 0, Q1, Q2. With Q2 being the final state, and the other ones just being almost state. With this is being the initial, pointing AB to Q1. Oh, pointing AB to Q2, sorry. Pointing AB to Q2. Pointing A and B to Q2 from Q1 as well. And Q2, A and B to Q3. And Q3 is self-looping. A is self-looping transition for Q3, and B will be pointing to Q1. B, not Q1. Okay. So this is what we want to minimize. So let's start with an equivalence. The equivalences, okay. Approach. 0. So we have setting Q0, Q1, Q3 to one state, and then Q2 to the other state. And then first equivalence. All right, we're seeing Q0 pointing to Q2, right? We're also seeing Q1 pointing at Q2. So if you see here, right, you have these two states pointing to 1, right? So that's why we are separating these equivalences. Q0, Q1, and then Q3, Q2. Now we're trying to see if there is any other changes, right? We have Q3 to Q1. But Q1 is not a final state. Well, and we don't actually need to merge these two together. I mean, we just separated, right, from them. There's no point to adding them more, and there is no relation with Q3 to Q2 pointing. Of course, there is a Q2 pointing to Q3 with transitions A and B, but there is no other way around. So we just leave it as it is. There's no other transitions that or changes that we can make to minimize our DFA. So the final answer for the equivalence, for the two equivalences, state Q1, Q0, Q1, state Q0, Q1, state Q3, and state Q2. All right, so how are we going to do that, right? So since they are together, we do Q0, Q1, pointing to Q2, A, B. See, A and B pointing to Q2. And then we have Q3 pointing A and B to Q3. And then a self loop with Q0, why Q3 is pointing to Q0 and Q1 is because since they're kind of like merged, right? They become the same. They don't separate where Q3 should be pointing the B transition at. So where should Q3 transition be? Since this is the same, basically, they become the same state. But yeah, so that's why Q3 is pointing to Q0 and Q1. Let's try to. I mean, we don't need anything else. This is basically final answer. I was thinking of building the DFA table, but I think it's pretty self-explanatory. Any questions? Do you guys want to talk about?
Go right and left linears.
Yes. Do you guys want to talk about left and right linears?
Besides that, is there any other concepts that he went through after the homework 3?
He went over the GTG, generalized transition graph. It's called, I think, generalized transition graph. Yeah, GTG. We talked to it on the last review. It is recorded. If you want to if you want to see it, it's I've sent a. It's on YouTube. Yeah, I've sent it on the group chat.
Okay.
Yeah.
That was gonna help you a lot. We went over it very detailed.
Yeah. I can send also the link from like in this chat actually.
I think I have notes. I was there yesterday.
Oh, okay. That's
Yeah.
so nice. Yeah. But besides that, we did not go over. I mean, that's what all professor explained to us.
Did he say that? No, it's
He-
the left and right linears.
Yes, he also mentioned that in one of the announcement that's what the two
Stuff is gonna be.
stuff are going to be in the midterm, which is going to be left and right linears and GTG generalized transitions graph. So I'll go to the left and right linear. I haven't practiced that part like a lot, so I'll be learning with you guys now. It's time. The time is 4:45. Okay.
Probably stop us 15, 17.
Do you guys mind if we take like 2 minutes or 5 minutes break?
Yeah, that's fine.
Okay, sounds good.
Yeah.
I'll stop recording.
Okay.
Or I'll just leave it. I'll cut it between when I post it on YouTube. So I'll see you at 4:50. I'll just watch my hands. I'll see you guys.
Rotate the line, and everyone doing a cool agreement, I need you do want to do something. Huh? Okay. Include go with you. Yeah, para como é 30 lá. Estou a estigar, cara. Só que não custa não me já tem gente de o grito normalmente é que é só com o grito. Vai ter na gente 30 vai ter gente está de brandada aqui de Samora. Eu vou botar lixo. Ele muda bem lixo no lá. Os campos ali, explica, liga. Os campos digitais que estão tão bem, tchau.
How in the form of meeting? From 650 instead of 660.
The joint of like.
I think so. Yeah. I think so.
Oh,
So yeah, I need to see the left and right leading in the door. So. What's happening?
it's not a shit. You didn't go over too much. Oh.
Did he put the new home? No, he didn't. All I'm doing is this makes sense. This one, is self-explanatory. It's an NFA, right?
You see, is that was an agent actor, it was like, it's NFA, but it's not, not everybody you picked, you remember anything?
But it said there was a DFA, the last one. The one that says ABSA. What is the time? All right. You guys here? You guys hear me? Oh.
Yeah.
Yep.
Okay. Okay, I'll start now. So let's get it first to understand, right, what is right and what is this is chapter 3, I believe, right?
I'm not sure, honestly. I think you're right, it should be chapter.
Chapter 3. So right linear. This is an 8, not an O. So we have like a variable, right? Let's say. And we want to like make this kind of like loop. Choose like restrictions or whatever. So this is a right linear because we have the variables on the right, and we always have to have them on the right if you want it to be a right linear. So if this was like this, that would have not been a right linear. It would have been a not regular grammar. And the left, I should have put left here and right.
You
Left.
block and then you push them.
Excuse me?
Oh, sorry. I didn't know I was muted.
Oh, so left, in here. Yes, so it should have been right, it should have been red, left, but it's all right. Yo. So for left goes the same, right? It goes the opposite, but the same approach, similar approach. So it's on the left side. And if we try and include something on this side, it will not be a regular grammar. Not a regular grammar. So what a non-regular grammar example can be is if we have a starting variable with A. And then we have A initializing as with A with, we can include something extra with this A or lambda. Okay. But then for the B initializations, we have A on the right side, on the left side. So the reason it's not a regular grammar is because they are kind of they should be either to the right or either to the right or either to the left. But this is one is wrong. Yeah. Not a regular grammar. Okay, so this is where, like, the next one is where we kind of like start and have to think a bit. So we have V0 with a V1. So now we have to initialize V1 as well, which in our example the professor gave us, it's AB V0 and or B. So what that means is we can end this A with a B, or we can continuously do AB and then start with A again, and then continue doing B1, choosing either choosing either single B or keep doing this kind of like loop. So how do we kind of build a automata out of this?
This is supposed to be DFA. You said.
Let's see if it could be a DFA, right? So we have V0 initial state, starting state, right? Because it's about the beginning. Giving A to V1. Yeah. And then with a V1, we have two choices, right? We can either end it. Let's start with the easiest one, which will send a final QF or VF. I mean, yeah, it
Doesn't matter.
It doesn't matter, but it's good consistency.
Yeah.
For our example. VF. The final state. B. And now what we learned was that, all right, we need this kind of like loop, right? That AB V0 is doing while we're pointing AB back to V0. So we need this state, right, that does this transition. And because we need them we need to send them separately, but they will both be sent to V0, but to this state. It makes sense. From this state. Sorry, not to this. From this.
That's one I think I understand. What did he name that? Just an empty state, or is it just like a trap? What did he name it at?
It's just a state that will help you. It's not
I
a
was thinking,
trap.
I was thinking like, why don't you just do like a loop from V1 to V0? Just name it BA or AB. You know what I'm saying?
Because if you do that, let's say right, why do we need this, right? But if we do this, right, AB, you give this, now you have the chance to choose only B's, right? It will break the loop of choosing in this order, in this specific order, AB. If we do this. So if we do this, we can do B, well, not just only B's, right?
I mean, but think of it like this. This way, A gets stored here, and A doesn't go to the V0. It stays stores here, and B goes to V0. So it's still the same.
No, but, well, remember, we're building a string.
Yeah.
We're building this combination. So that we will send eventually to finish with the
Yeah.
final state of VF. So let's say, right?
Wouldn't it be
Let's
like,
say, okay, your idea,
wouldn't it be like A, B, right?
but it's not done yet.
It's not done yet. Okay. A, B, and then A, B.
Yes,
That's okay. So this one will be A or B, so A, B. So we still have A in the front.
but the starting
It's zero.
state starts with A
Yeah.
and then AB.
Or wouldn't it be, for example, like in the first one, it will be A, and then B, then AB.
But when you add AB with this transition, you are giving more combinations. You're giving more freedom to do other combinations. Which we don't want to include those
What are we
in our
gonna do this
machine.
then? Oh,
Because it's a,
I get you, because you're missing it, you're missing an input, because this one will add a string. If we do this one, we'll eliminate a string.
exactly.
Can we do A and B?
Well-
Like this one this input has two inputs at one time, or is that possible?
It is possible, but not for this, linear, which is a right linear. Yes, the reason is because we give these possibilities that are not correct for our machine.
I completely forgot that it eliminates a string, eliminates.
Think of it this way, right? Always your goal is to,
Okay, or whatever it wants to.
yes, to operate based on what it's telling you to do, you know?
I was trying to think of another way, but I forgot that if you take this away, you eliminate the string, and I completely forgot thinking about the whole input, like.
Yeah,
it's a whole
so
string.
one of the, like how we can think that this empty, well, it's not empty. We're just not naming everything, so we can kind of give this idea that why we're using it. We are using it because to separate A and B from each other, so we can always send it in that specific order.
Yeah.
Because if we do from V1 to 0, we do A, B, right? We can end up with A, and then we can just do B, A, B. And then it will not, it will have this, it will, again, will send V0, right? Which will need A, but then that transition gives you the opportunity to choose B again, which will kind of like will send you like into this never-ending loop without sending the correct, like the correct
Yeah.
combination string, if it makes sense.
You know, I understand. You know.
Okay. So yeah, that's one of the examples that Professor went.
You need to
Any
do the
questions?
traps too, don't you?
Excuse me?
You need to add the traps as well,
But
because it's not a DFA right now.
Oh, yes, yes. I mean, do we need it to be a DFA? I'm not sure.
In class, we were doing DFAs, yeah.
Okay, okay, so then it's a AB.
Did he edit the notes? Because I remember him saying it might have been impossible DFA.
Yeah, I mean, right now it's an NFA, so it would be good there, but if you wanted it to be a DFA, you'd have to add the
Yeah,
traps,
okay.
yeah.
Yeah, I don't have it written as a DFA in my notes.
That's what I think he said, possible DFA. It's like Parker said, if you put it.
Yeah,
Put
of
it.
course.
Did we do this one in the,
Yeah, with this one.
Yes, we did in class.
Huh.
It's the first example
Yeah.
of
oh,
regular
yeah,
grammar.
oh,
So-
that's right, yep, we did, I just had it written real small. Yeah, that's right, then the next ones we did as DFAs, you're right.
Yeah,
Okay.
it is. Yeah, so, but that's good. I didn't know that. I did not.
So this is a possible DFA. Well, it kind of, yeah, what we can,
What would the trap? Would the trap be where VA is or no? Or would it be
So
somewhere else?
like anywhere you have a node that's not handling one or the other cases, it would be sent to a trap. So like from V0, if it got a B, it would go to the trap. From V1, if it got, or no, not from V1, if from the final state it gets an A or a B, it's gonna go to the trap. And then from the one that's like kind of between V1 and V0, if you got an A there, it would go to the trap.
So
You see what I
basically,
mean?
here we'll put the trap B, and then
Mhm.
here we'll put A. I mean, V doesn't, we'll just put A if it has any, but there's only won't be a chance where it gets any.
Yeah. Yep.
A B though, for final state?
Yes, because it's a final state.
Gotcha. But do we want it to trap B?
We do want to trap B because,
Yeah, because once you get to the final state, you can't accept any more input.
Oh, okay.
so
Gotcha.
this is kind of like, that's how you finalize your string, your combination string.
One more time, just so I can refresh my mind, because I think I missed this in class when I was away. Since when you include in the chat, kind of like eliminates them, you know, like from the actual total string, right? From like the final output. For example, like would it be A, B, then A, B, and then it would just disregard these A and B from the actual output. You know what I'm saying?
Yeah, so it blocks to include the
That's what I
combination.
mean, like eliminates it, but doesn't actually eliminate it, it just puts them away. Right?
So it just tells you, hey, you cannot do that.
Okay. You can't, they can't be part of the actual output string.
Yes, exactly.
Okay.
And yes, don't mix this with a trap. This is not a trap. This is kind of like a bridge for.
Honestly, you should put like an and sign.
I'll just this is much more.
I'll leave it empty, but it would make sense kind of, you know, put an and sign. But you are kind of combining it. You know, I saw another expert naming their trap fee.
That makes sense because you're not like allowing to have any combinations anymore, like any more transitions.
Yes. Here, another. You didn't go over left linear, did he? He didn't go over like a good left linear example during the class. It bothered me. You only went over right linear, and at the end,
I see.
we went over left linear just like the little bit, but didn't actually. I mean, does he really need to go over like the building and the constructed? He doesn't really need to.
I mean, yeah, it will probably like be
It'd be the same thing.
which we'll probably have in exams. So we have to do that,
Exactly.
which is pretty funny. So let's start the other one, right? The other one is S A B A, then A. Oh, sorry, this is a arrow. A B, then B, A, capital A, or B. Okay. Okay, so we start with the first, like the initial state, which is S. Just pointing AB, this A state, right? Pointing AB to this A state. And just like we said before, it's in a specific order. It's A and B, it's not BA, right? So if we do this, AB, it will be wrong because we are given the possibilities of other combinations rather than AB. Well, it doesn't make sense. No, first of all, it doesn't even make sense because you'll just choose only one variable, one transition. First of all, but yeah, so that's why we need that bridge. I'll call it bridge transition. Okay. I'll name it here. Bridge transition. I'll make this is empty kind of circle. So we have A and then B. All right. So now we have A with the B state, which is pointing B and A. Which is going to be the same thing, right? B, A. Now we have two possibilities. So the first one would be just straight sending it up to the final state, which is going to be just, I would just call it QF now. Which we will send, okay, how will we do this? This is going to be two Bs, right? I'll check the notes a bit. I guess it'll just be, I think it'll just be the same, right? It'll just be the same here. BP as well. we still need a bridge state. Now we are left to solve this one. We want to send a transition to B. Does this look correct?
I think you may have done like too many like bridge statements. Because he just actually connects them like to each state. That's yeah. Or no, I think it might be incorrect. Let me see again. No, you're right. You're right. I'm sorry.
Okay.
That was good.
Okay, so now we have so many like transitions, right, that are not included, and we need this as a DFA, so we have to create a trap for those. Where I'm gonna create a trap is basically probably here. So I'll start from final state, or I'll start from the initial state actually. Initial state has A. It doesn't have B, so I'll just send B. Trap. We also have to be careful with and not forget the bridge states, yeah, because they have transitions as well. So this transition from S to A is transitioning only B, but so we need to send A to trap, and the same goes to here, but instead it's A rather than B. It's B rather than A, sorry. And here is A rather than B. Now we go for we're trying to aim for the other states, which is the A state. We have B. We send from A. We send A trap.
No. Sending B, A.
We sending why
Would you put B or A for A?
A.
Oh, you did put A. Okay,
Yeah.
sorry, it looked like a B.
Okay, sorry. This is A, by the way.
Yeah.
And for B, we don't have to put anything to trap because both transitions are being used to be sent to different states. And we got rid of this bridge state. And now the final ones are the trap and the final state. So we send, for the final state, we send A, B, and then we loop A, B to the finals, to the trap state.
Explain the reason why the B doesn't have a trap state. It doesn't send anything to the trap. Is there two transitions going?
Which B?
B, like the actual B state, the state.
B state, why it's not sending to a trap?
Yeah.
So because of this, right? We want to send, let's say the example, the most simple example, right? S or A, B, and then B, A. So this turns to B, so now we have to see it at B. And this is A.
Yeah. And then B.
A. Oh no, this is A. We can have two possibilities, right? But let's choose the easiest one, BB, the one that you had the questions. So we have to work this combination in our machine, right? So we start A, B, and then B,
Again.
A, and then B, 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 B.
Oh, that's why it's not listening, because it's actually completing its own.
Yes,
It doesn't have any access.
yes. And dealing with the little a and A capital from B state, we're doing this, which will from A, then we can come back doing BA again, and then when we are at B state, we can choose AA again. We can gonna loop back, or if we want to finish, we can just finish it with the bridge state.
So, for example, then A would not have the trap if A was sending A, then B. Because look,
Yes.
A is sending BA.
Yes.
So why was this still sending a trap?
It's,
'Cause look,
no. Remember, the bridge is sending A to B,
okay,
not A.
but B is only sending it to the transition. That's it. So
Yes,
two.
and then sending A. But this bridge is getting the work done for
B, so that doesn't count for it. But B
B is only, oh, so B is telling it to send A, but where's the other B? This person said, doesn't say you have to send two Bs?
Yes, so one B is right here, right?
Yeah.
And the other B is here. This is this, right?
Yeah, but
And
that doesn't count, it doesn't count for it.
For A, you say?
Yeah.
The A is right here from B.
No,
Okay.
I'm saying for, you said for state A, we're sending B and A, but you can't count the transition part of the A's. That's what you said, right?
You cannot.
Count it, part of like, it's like A's original transition for this one right here.
What I said is, this bridge state is working as a transition for these two states, which is B and A. Because you need this, the reason why you are doing this bridge, you're using this bridge state is to give in a specific order the transitions from A to B, which is B and A transitions.
Yeah, I get that's the same thing is happening for B. Right?
Yes.
But what makes a difference for B? Because B has both its inputs being sent.
What makes it a difference is that B has two options. It gives two options, right? It gives an option to go back to and start looping again with respect with A state, or just giving a final, a definitive answer,
B.
combination of two Bs.
So for example, if we didn't have sending it to A, like if this didn't building diversity exist, so then we'll have to send A to the part of the trap.
Can you repeat again?
If B wasn't supposed to send A back to A, then A would go back to the trap.
Yes.
Okay, gotcha.
Yeah. But no, but depends if we just have BB included. If we only have capital A included, that would mean, I don't think that would even, I mean, it can make sense, right? So now we can choose either finish it with BB, or we can do A, which is going to take BA, right? And B. So how that can happen is, you're just going to create another bridge, right? Where you do B, you send B and A with pointing back to B. I don't think that would make sense. It would not make sense. You know why? Because it's on the left side. So we need the right side always. I think so. Yeah.
You're right. You're right. I mean, but let's say A didn't exist there too.
I would just send BB straight.
So then, but then B would just send an A to the trap, right? If this,
It will send with a bridge. It will send BB.
this did not exist.
It will just send BB.
But would it do a trap to A?
It will do a chapter A.
Okay,
Yes,
that's-
correct.
okay,
Yes,
that
yes,
was the whole
yes,
question.
Sorry. Yeah.
Okay, but I'll put it back so you can, finish the question.
Oh, yeah, I mean, the question is finished, yeah. You guys have any questions? Should I move to the next one?
Yeah, I don't have any questions.
Okay.
Second to last. Another part is simple.
The next question is, S pointing to ABS. Oh, no, that's what I did, right? Or, no, that's,
What was it?
no, I'm thinking if I did this correct.
Which, let me see.
Is this the same thing? I think this is, no, it's not the same thing because we're including A as well.
a different right here.
Okay.
ABSA.
Okay, so no, well, it's
Which-
gone now, but
Which one is it?
no, I gave an example like for the
No.
previous one. It's all right. I said something wrong, which the if we remove the little a, okay, let me say this because I said something wrong. If we do this, right, AA and then BB, and if we remove this, but still the other things are on the right side, they still will be included as the right side. I couldn't think of any, like for that exact moment, I couldn't think of any like solution for this type of problem, but that was wrong what I said like 5 minutes ago. Just so can be on the same page. I just jumped in a conclusion very fast. I shouldn't do that. All right, guys. A then A, B, A. A, B, B. A. This is okay. This is good. All right. So let's do this. We start with the first state, which is S, the initial state. And we're seeing that it ends up with an S. AB ends up with an S. What we can do is, since we'll always end up at the S state, right? It will end up to itself after sending AB. That means that we can send A, and then after returning, it will still be in the exact state where we wanted it to be. S, which is S. And now for A, for the A state, let's say since we use A, right? Since we use A for our S state, and we want to include all the transitions per state in a DFA machine or automata, DF automata. Here we're gonna send B. Now we are
I don't think that's what we did in class. It's not what I have anyway.
You're right. It doesn't make sense. It shouldn't send it to A. It should probably send to the bridge state.
Yeah, big state.
Yes.
This one was a bit confusing.
It does make sense why it's sending to a bridge state. It's because you're not valuing anything instead of assuming that since it's maybe a DFA should be sending B to A. You shouldn't assume that. Instead, should use that B to a bridge state. But the thing is, are we sending, or are we sending? I don't know. Are we sending A first and then B to
No, you're saying B.
Yeah, we send B.
to A, right?
The bridge
No,
state. The B.
B.
It was B there.
Okay. B.
Make it more down because there's all the.
there's no
B.
direct transition from S to A. It has to go through B.
But make it B though. It's not A. It's not A state. It's B state.
Which one is B?
Yeah, B is
There's only one
where
is-
you have A right now should be
Actually,
B.
B.
Because
Oh, because of the
he
BA.
said that S, yeah, so like
I move it more
at the
down.
beginning, S and A are gonna be the same state, is what he said for like a moment. So like you have to do the transition for A from both like, so from A to B, right? You're gonna have BA to get to B from A. But you also have to have BA to get to B from S because technically S and A are the same state for a moment, is what he said in class.
Yes. Oh, I do remember that.
I did not
Yeah, it
remember.
is kind of confusing, yeah.
Okay.
Drive it more down because we won't fit in the other stuff.
What? Wait. No, but it's okay. We can figure. We have all these like
Okay, so-
things. We don't have to make it like a triangle. We can put the trap here or something.
Gotcha.
It is a trap. It is. Yeah.
Yeah.
I
I
do
don't
have to
understand
get
the
going
email.
though. Thanks for doing this.
Yeah. No problem. I'll just keep recording.
Yep.
Trying to figure out.
Oh, so just you. Everybody has left.
Yeah.
Okay, well, we keep recording and anything we'll send it on YouTube.
All right. Thanks, guys.
All
No
right.
worries, man. Take care.
Good luck tomorrow.
Likewise.
Good luck. All right. So for the moment, we have to write this. For a moment, for a moment, S and A are the same thing. The same state. Okay, for a moment.
Yeah.
The reason is because of this restriction here, or not restriction, but this
Choice.
option. Yes, choice here. So we have to kind of, for this bridge state, we have to include A pointing B there, because think of it like this, right?
Okay, first, let me go in the beginning so I can follow a bit. So first, this is what I'm understanding, right? S state goes to A, bridge state, right? And then that's part of this.
Yes.
A, right? And then bridge state back to S, so that's where you put bridge back to B, right? That's the
Yes.
part of it. Is this also part of this, S, A, B?
This is not part of that. This is part of this. So the reason
Why
why
is it coming from that? Why is it coming from S?
the reason it's coming from S because
this,
yes, A is part of S for a second.
for the second.
For not a second, I just
You know,
meant it
yeah, you know what I mean.
for a moment.
For the purpose of this.
Yes.
This is option. Okay, then that's where we get B8 to B,
Yes.
and then from B.
Let me
A.
circle this. Let me circle
Yeah,
this.
I'll put it on my notes.
To kind of like highlight the arrows that are going. Why is that happening?
Okay, that makes sense. And then make this one to here.
Which one?
I highlight because of this option right there. Because I'm not, actually, yeah. Okay, and then since we have the following it, so that's part of it. We're done with this one. Then we got.
Turn up.
Yeah. Then we have B to AA. So
Let's try to focus first A to BA, right?
that's
So-
part of it, right?
Yes, yeah, we're just trying to like.
Oh, but then the actual part of it.
Yes.
Okay.
So the reason why we include in A here is because we still want to end up, if we choose A straight up, if we choose straight up A, right? It's
still
just
have
going
to
to be BA or BA. It's going to be the same thing, right? But the reason why we include A here as well is because
It's actually part of this, a
Yes.
different state.
yes,
Yeah.
correct.
Okay, and then since we did
Now-
BA, then with this one.
Now we are at B state, right? We're sending A to A. But how?
Bridge state?
I don't think so. I think
No, it's not a
just-
bridge state, yeah, it's not a bridge.
But let's do the BB, the final state first. UF. BB, right? Should be BB. Or no, it's a B, because B bridge state B, right?
No. It's just B.
B straight.
The final state.
Are you sure?
Look at mine, right? B.
I have it different.
Do you have it? Do you see it?
I probably missed it then.
Most likely missed it. We'll have to see in the parking see what else someone did.
So, well, just like we did it last time,
It would make sense for it to be a bridge.
Yes, so this is a bridge because of this one. Okay. And now we have to worry about this. So it's just
Eight.
Yeah.
Okay,
now we have to include the trap.
make a deal.
Yes, so the trap, let's do final state A and B. B, let's do this one, it's sending A. Let's use, or let's use green.
Look at five though.
B and then A. So B is not doing any trap transitions. A is doing B, so we're sending A to trap.
This is a bridge state.
This is sending B. This is not sending anything. This is sending A. Sorry for kind of like making the lines confusing.
And
Hopefully
since
it's
you know,
understandable.
bridge doesn't have the trap because it fully completes this option.
Exactly.
Now, my thing is this. I remember some other grammar that had like two inputs, like they had two lower cases. Is that, do they always do a bridge state? I don't remember, like in the beginning when we were learning grammar, where some of the grammars have like two small, like lowercase variables, or did they always have lowercase, uppercase, lowercase?
Never, we never build a final state out of a grammar, right?
Let me make sure. We go, that was chapter one, yeah, chapter one.
We would never build a machine out of a grammar. Until now.
This makes sense though. Yeah, you're right, yeah. Oh, we're here though. Right here, would that be part of like, would that be including bridge states?
That what you're let's try to.
Grammar continuum.
I think that would just be difficult to solve. Let's try to solve this one though, for
Look,
example.
I'm just trying to find out when is the, when.
Can you show me that again? Can you show me that again? Okay, no.
We're also
it's
talking
a
about-
similar problem, but
This is the part of the notes right here, if you can see,
yeah,
this right here.
right here.
Right, I have a point on my finger right here.
Right.
These ones right here. How there's like two lowercase variables. But I'm thinking about in the actual exam, when is, let's say he gives us grammar and it just has like one. When do we know to do use bridge states and when do we know to not? Right now, what I'm thinking is we use bridge states when it has like two variables, like two lowercase variables, something like this. That's what I'm thinking of
When-
making bridge states.
I think, yeah,
That's the only like time like I think like, oh, it's bridge states, two lowercase variables, I have to do a bridge state.
bridge states will just make sense when to use it. I think it just clicks to you, right?
I think so.
Bridge states are more like making something in order.
Yeah, I know, but like I see like I saw some of them. That's some of the grammar that had like two lowercase variables. I don't remember if we did like an actual build like a.
We never built a,
Okay, so there was nothing to work.
we were just figuring out how to do the language out of it. Remember, we're building a language out of a grammar or vice versa.
And then the language building, the constructing the NFA.
Yeah.
So now, we know 100% based on the grammar, always, if there's two lowercase variables, always make the bridge state.
Yes.
Alright, what should we go over a little bit?
We go over the last one again.
Always the last grammar, the last linear,
Yes, so like building right and left linears based on the language that is given.
that's actually a good one, yeah.
I think 100% an exam.
All 100%. maybe.
This one is going to be 100% an exam. So the notes. So. Construct left plus right. Linear
There's right for left for linear graph.
grammar. Left plus right linear grammar.
Linear graph.
Grammar.
Grammar.
It's grammar because we're doing grammar.
So what did I say for? What is going on, bro?
All right, let's do it. Let's do it.
Quick, so we can go home. You need.
I need, man, I swear. All right, so for the right linear, right? Okay, we need the language first.
Yeah.
Yeah, right language.
A
Language is,
to N.
A,
I'll tell you. A N. B M.
E, M,
Colon. N greater or equal than 3.
and greater or equal to 3, and
Comma. M greater than equal to. Close bracket. And then we
these are
have,
language, right?
and then we have
So-
right linear. Or you
For now, we're just doing right linear, right?
Okay.
Or we're doing left linear. Let's do left linear first.
We have to do right first because it was mentioned first. It's like right for and then left linear.
I think there are two different things, right? I mean, we just approach it that way, but
Okay.
let's do left linear first. Because there are two different grammars. There are two different grammars. Or I'm just not going to equal grammar.
I think it was supposed to be 4, not plus. Because we have 4 grammar. We have 4 right. Right, 4 and then.
The plus is like and. I'm just
Ah.
using plus and
Ah.
and.
Capito.
I'm using, by the way, plus just because I don't want to use and. Or just.
I think I'm the only one that gets the issue.
All right, so the first one, the minimization, right? What will be the minimized A's and B's that we need in the first, like the first combination that comes to mind, right? There's gonna be A, okay, it's gonna be A to the 3 and then N to the 2. To the second power. This one. And then we do A, B, B, right?
Shouldn't it be 4?
It's 3 and 2, right?
What is going on? Sorry, continue.
The reason is why, okay, let me explain why. Go left.
Yeah, continue.
Left ring. So what we're trying to do now is start from the left, right? Or you know what? We should have started from the right. It's much easier to understand because we've never been used to doing left first. Let's do right. You're right. Let's do right. But it doesn't matter actually. Just much easier to understand. Right linear. So what we're trying to do is we can add as many in the right linear, right? We can add as many A's as we want, but on the right side, right? It's going to grow, the combinations will grow from the right. So what we can do is we can either add them or not add, like we can either add as many A's as we want, or we can choose to not add at all, right? So that's why we include the A star. I'm just gonna do R equal to,
I said it was 4.
right? And for B, it works the same, right? First two, and then the third one, the B star is gonna act as, we can use it as a lambda, or we can use as many B's as we want, but the minimum has to be 2. And minimum for A's has to be 3. All right? So that's how the starting, the initial variable starts, right? With 3 A's, capital A, okay? So now, for A, right, what are we gonna choose for A? So it's gonna be either another A. The reason why we adding a capital A, so we can continue looping it. Because we have an A star, right? We concluded, yeah, we concluded that we can have as many A's as we want, or we can have a lambda, or 1A, an extra A. So that's why this is it. And we need to include the next kind of state that we have to work with, right?
I have a question. Does it matter if you do comma or actually like that line?
It doesn't matter. I think it'll just, I don't know. I think because how everything is constructed,
Yeah.
it's much better like this. All right. Now, for B, right? For B, we can include,
BB?
yes. So the reason why we can include B, right? Or we can include BB is because what if we don't want any A's at all, right? So we just end up with BB. And that's where it finishes. But we need, because of a B star, right? We need this other constant. Let me keep it more straight because it's kind of like we need this capital C, right? So now what we can do is for the capital C, we can either end it, right? Keep it just B's with a lambda, or we can do just add more B's.
B star.
BC.
It was supposed to be D star, no?
Is it B star? I think it's going to be BC. I don't think stars are included in the.
Because I don't know, maybe I did it wrong because I don't know.
It's going to be B, right? Think of it, right? So now you are in this position.
Yeah.
When you are in this position, you have nowhere to go but either continue doing B's
Okay.
or
So there's no
lambda.
for actual B star. If I put actual B star, things gonna mark it down?
I think so, yes.
Okay. I don't, because you didn't put it, so I guess.
What you're doing is with a B star, because you're including B star and B star C, I think.
Yeah, B star C.
Yeah. So what this B star C is saying is include any combinations of B, so many B's as you can, or nothing. So you're doing lambda C, lambda, and then B, or B, B, or B, B. So you're including this, right? And you'll end up not choosing any B's at all. You understand? Like if you do B star.
Oh, okay. Gotcha.
Because you can have the possibility to choose only lambda with C. Does it make sense?
Does the order matter?
It does matter.
You know, and then in the note,
It doesn't matter, but
so it does or it doesn't?
it doesn't matter. But just for the sake, it's a BC.
Does not.
Yes,
No.
does not matter. Sorry.
It's the same thing if they can.
But yeah, it does not matter.
Should we try to construct the DFA, the NFA or the DFA?
Let's try to do the
Left.
left linear
Okay.
first. And yeah, after that we can try. Left linear. So left linear is putting the A star or B star like as a prefix, not a suffix, basically. That's what the left linear wants you to do. So let's try to do that, right? I'm gonna remove this. All right, so let's do R, A star. Remember, it's left. Remember, it's left linear. And then we add 3 A's. And then again, B star, 2 B's. Okay. So let's build it. Let's build this. So we start, right? We start with the initial variable. It will just be
A.
yes, it will just be exactly A with
3 A's.
3 A's. The reason why it's not A with a capital A or B or either A, B is because we need a strict order, right? We need exactly how this is ordered instead of choosing B first. That will not be our exact order how we want it, or what are we being asked to do. So that's one of like the reasons if you get that kind of stock for that. So let's go for A, right? Capital A. Capital A. It's A capital and A, right? Or B. Why is it B? I'm thinking.
It's just what it says.
I mean,
Wait, why do you put AB then?
excuse me?
You put AB on your notes.
Yeah. No, but why?
No.
This is wrong. This is left. This is left. Left. This is right.
Yeah, we're doing left right now.
We're doing left.
Yeah, you put. Oh, you have A, B. Okay.
But why we're putting B? Oh yeah, you're right. So it's wrong. What I did is wrong, actually. What I said in the beginning that could be wrong, that's the correct one.
Yeah, I have AB too.
Yes, so it should be A, B, B instead of, because of the order matters. This is correct.
And then the top one is also. There you fix it.
This is correct. So that says A, B, B, by the way. That's why I was confused. Okay. What this can, why we shouldn't be A is for the reason that I said it last time, was because it's in exact order how we wanted it to do, right? And for the left linear, think of it as like in Arabic, right?
You're leading from right to left.
Yeah, like in Arabic, you're reading from right to left.
It did say that.
Yes.
I think he did say it in the class.
So reading from right to left.
So the left linear is mainly where it's ending.
Yes.
Okay,
So
makes more sense now.
so now it's okay for A, right? What do we want to add for A? That is going to be, is it?
It's just B, AB. Because we include AB, capital AB.
Well, it shouldn't
Yes.
be, but it's a left linear, right? If it's,
That's why we're putting A first.
but then this is on the left, right? This is on the B, right? On the right. This is on the right side. This is on the left side.
No, this part doesn't really matter. This doesn't change the order. Just this minus the order. These stay the same because it's like or. I mean, you could do this, you know. You could do this. What was I saying? You could do this, yeah.
Okay. No, I thought you meant. Okay, never mind. I thought you meant something else.
Oh,
Okay, but for the sake of it, I'm just gonna do AB. Why? Trying to understand why you. Just gonna like Keep it this.
This is, no, I meant like, what we doing the other one?
I just messed it up. I just, it was my
I think
mistake.
it was doing like a BA.
Yeah, I meant to say AB.
Okay, gotcha.
AB. Just for the same reason, right? We
Yeah.
want to include many Bs as we want. B star. We are at B star right now, right?
Mhm.
We want to include as many Bs as we want. And then if we start to choose B, then we are going to the A's. So we are doing A, B, or C. Is that correct? Let me verify.
Don't check it. Don't check it.
All right, let me verify.
Think.
Let me verify.
So right now for B we have BBC. And then. Yeah, since we have the three.
It's BAA.
Yeah, so that's first the one, that's the first correction.
BAA. B A
A, C.
A.
C.
So AAA, right?
Yeah.
So now for C, for C now we gotta go to the next one, which is gonna be.
No. You have to be careful, but come on.
How come miss them out? I keep missing it out.
I know.
C is funny. Or lambda.
Yes. Now let's check.
Let's check now.
That is correct.
Okay, that is correct. Yeah.
There you go.
So just remember always.
Wait. No, for B, should be CAA.
CA, right?
Yeah, for B, you put BAA.
Or that could be a. Yes, it should be BAA. The reason why,
Yeah, why'd you do that, bro? Because this only has BBC.
because I was
correcting you too, bro. I was saying, yeah, you're
I
right.
was just trying to figure out myself,
Yeah,
like without looking at the notes, but
yeah.
okay. And I kept misreading the notes. Like I was reading the other
But you
side.
have, yeah. You should cross it out. You know, make it or like do it with a different marker.
Yeah, I should.
Yeah. What do you think?
Let me do it.
But you
Let
can
me
still
do
see
it.
it. I wanted to make it.
It's all right. I can still see it.
Okay.
So yeah, this is the. Let's try to build it now. Let's try to build the right one, right?
Yeah.
Which is most simple. Well, if they're both simple, it's just you get confused.
Keep that. Keep it. I guess don't keep it. Makes it easier.
Well, it's wrong because
But no, it's not. It is because it's left.
Yes.
Yes, you're right.
given a language,
Yeah.
let's do the R, right? R equal to A star, B star, double stars.
Okay, so let's start with S. Then
S, right.
So all of
Start
these
with
are-
S.
Hey, based on this, I want to see.
Oh, I think we're gonna have two bridges, right?
No, I want to see this one. Which one do you think is the initial, the final state, not the initial? Do you think S might be initial state? Final state?
I'm not sure. You check, do you wanna solve this?
Yeah, this is a relaxed one.
I need to
I'm
really.
just trying to see like, try to see patterns, like with the grammar to see, find out which ones are the final states. So, first, always have to draw the arrow, because it's probably gonna take, the grid is gonna take points away for that.
Try and make that.
Yeah, right there. Yeah.
Yes, of course.
Okay, so we have three, well, you can't see. Well, flip this way and then turn the other way.
They're not seeing either, so.
I know, don't worry.
Oh. I'm making the video for them, actually. I'll still see it at the end. So I think we just need two bridges, right?
Yeah, so actually, yeah, you're right. Let's
Two
do the
bridges
first.
first. It's 624, I think.
That's crazy. Almost-
It's not a capital A, it's a small a.
That's what I did. Small way.
Well, it looks like a capital A from this side, sorry.
Oh, that makes sense, yeah. And then just put it. And then we have A to A, so that's a loop. Right?
Remember how, like, if we're trying to find patterns, right? The B was when we had two states in like trying to initialize it, right? We were saying that A could be for a moment B. Remember A's could be for a moment A.
No, but that was different because it had that.
Yeah, for A has.
But it doesn't have this.
No, go up, go
Oh,
up to the
yeah.
next one.
Yeah, right here, right here. But we're still here though, so we're not doing that yet. You know,
Well, you should have done another state. Sorry.
oh, another 3 states?
Yes, because you need 3A, right? Before going to the A.
Oh,
capital
yes,
state.
yes, right. Oh, no, this is right here. This-
Oh, I did not see
Yeah,
it.
I forgot to put that. My fault. Okay, so now let's focus on this one. Saying we're saying, well, this will be the, so now we're gonna have. So A won't have a trap, anything, we know that right away, this A won't have a trap just because it has this B. Right?
Okay. Following.
Just because like this part, it has 2 outputs. Or is it because it has to have another, it has to have a small character?
I'm still not sure if he has a trap or not. What I was,
Because is it DFA or not?
leave the trap like in the end.
Yeah,
Trying to figure
that's what
out.
that's what I'm gonna say right now.
Yeah.
Okay, so now AA, that would be a loop because this is the basically the A star, right?
Yes, but what? Yes, yes, yes.
It should be me on that.
Well,
Oh,
how we did it for the, how we did it last time was,
I completely forgot how we did last.
it was, remember, we started with B first. We pointed.
I know, I'm following you, I'm forgetting. Oh, no, it's not a loop, it's an initial, it's another bridge,
Yes, it's another bridge.
it's another bridge, that connects it to. What would have to,
What I would say is,
and then. Remember, also. This bridge would only, because if this had like 2 characters, 2 lowercase variables, because it would be connecting. So right now at that point, we know. Oof, but
this is a little bit difficult.
this is one possibility. I'm thinking either B, let's just try it here for a minute. Right? Has here, and then. Which way?
B, another
No,
B,
let's
let's
say
say.
another insert. Sure.
Okay.
That's the simple part, and then the A to B. I don't know if it'll just be this.
Can I see?
So. I don't know, I'm not, this is the one I'm sure about, because this, I think it just means this though. I think this A, and then the B connecting, I think it just means this. I think we didn't build this.
No, I
Let's
just
see the other parts.
I just have to see how we did the A, B in the same state as S. For a moment. We never had the option where we could send A. We can transition A state. No, we can.
Oh, I wrote that to the wrong place. Oops.
We never had like an example where we're transitioning little a back to A, capital A, but I think.
What I'm issuing is this. With the A to A, that one is easy. I don't know. Should it be a bridge or should it be a loop? When was the last time? Because I remember GTGs, right? The loops are the stars are the loops. You know? I'm sure that's what I'm basing it
That'll
on.
be different. No. Yo, you're mixing it up. That's an R. Don't mix R with a star. Remember, the loops are the R's. Don't include the stars.
I got you.
Yes.
Well, let me see the right linear again. SABS.
See that one, yeah, that one is different. The moment that become where it's SA is from moment A is because it has 2 lowercase variables, 2 lowercase m, 2 inputs. right? So if, for example, right here, we had A to A, if I had another A or a B, and then the B, that's what it would be like it will be like a slight difference.
But I don't know. I think you might still have to use bridge states. Let me see here. So. Wait, I think I got this. Give me a minute. I think I'm onto something. I think I'm onto something.
A becomes, that's what becomes, so B becomes BBC. And you're right. For that moment, I think in the moment you do this, you do the one below it first, then this one. You're right about that.
Yeah.
So let's do BBC. So that will start from initial. Now where do we go from it? We start from directly from here. So we'll go B, bridge, B, C,
Well, no,
not C. Wait. Yes, it would be C.
it won't be C
It would be C.
because B and A are for a moment initials.
Right here. S and A are together initials. It goes
Yes, but
B8 to B. Right here, because it goes from B, and then bridge state A to B. But you have to follow this one. And then you follow, and then you do A. Then you go from, then you says here. A, B.
But you are doing it with the S. You should do it with the A instead.
No.
Oh,
So you should do A.
yes. You're right. You're about there. I confused it because that one was a different example because it was right in the beginning. So then A would be B, bridge thing, and B. Then that would be C still. And then B, we can put it right here.
What if you just point? No. What if you point? If you point A to the,
A to C.
if you transition a variable of little a from B to A.
From B to A. So like this way?
Yeah, instead. And look now, it says A goes to A, right?
Yeah,
And then BB goes to C.
yeah.
And then, but A can be for a moment as B as well, so that's why.
I see your point.
But I'm still not sure if it's correct.
I don't think it might be, I think it might be B. Wait. What I'm trying to think is,
The AA, right? I think it should loop to itself, bro.
no, remember this, when we did the in here, from B state, where do we get the A from? Connecting B to A, where do we get that from?
What?
From B state right here. Where do we get the A input to connect to the A state?
Right here. So you see how B, A, B.
So then, bro, what about this one? C, B, C, that is just a loop? Huh, what do you think? For the last one,
Yes, I guess so.
and then where's the
It's
lambda?
fine now. It's C.
No, lambda.
It's C.
What?
Because you may not choose it at all, and you just finish.
Oh, C is lambda?
Yes, C is final state, basically.
Okay, gotcha.
Oh, but now it makes more sense. So like why C and lambda are the same for a moment? And why A and B are the same for a moment? You can get this example from this states, right? So you see how like C and lambda for a moment the same state?
Yeah,
Because you want
because of
to
the same thing.
finalize it.
Yeah. Well,
You're blocking.
oh, no, alright.
But yeah, but now, well, I'm trying to figure out the first example from the professor. Okay, so the one that we made like 2 minutes 10 minutes ago.
Yeah.
A, B, S, okay. And then when you send it to A now, it's B, A, to B. Yeah, so. So. Goddamn.
I still don't understand where we get the B from B to A state connected with A. That's what I don't understand. I forgot. Well, I think we figured it out.
From this one.
Oh, I'm stupid. So yeah, that's why B state's all by itself and they're just feeding to A.
Yeah, that's what I
Because
was.
nothing is connecting it to it. Or yeah, well, A is connecting it to B. No, that's option B. It's different.
Let me try to figure it out. Let me try to figure out this example first, so I can kind of like link it.
Let me take a picture of this and you can show it to the professor tomorrow and see what he
So
says.
here it says BA to B, right? So it's sending, this one is still sending to BA.
All right, go ahead. 15. I think Rob be right.
I think what you can do here is for the AA, right? I think you can just do. Well,
For this one? No, that's two A's. I mean, let's think it back to this. So this is our.
Yeah, so let's say-
Well, this is our DFA, NFA at the moment. Let's go back to the language. Let's just start by the language, right? So we have A and it has to be more than 3.
1, 2, 3.
3. That's one of them. And then B 2.
1, 2.
So that's still 1, 2. So we're still in the correct because we have 4 A's and 2 B's. Because look
But
at
this
this,
is wrong. Yeah, you're right. You're wrong. It's wrong.
this one.
Yes.
Because I'm thinking like this, A star. How can we have infinite of A's? We have a finite of A's. This has to
So I
be
guess,
this. Either a loop or that. It has to be that.
yeah.
You know. But then for B's, 1, 2 specific, and then
B star, yeah.
Yeah.
So it should be this, right? But what happens to,
B. I think B is just this.
well, it's not that because you need the specific 2 B's.
I mean, it is. So it's 1, 2. Because B doesn't say where the B goes to BBC. You know. I think this is goodbye. And I think Jared, put this B. Where's the green one?
There you go. I'm still thinking. I should read it first. I should read the whole thing. Like, properly.
Like, that's what I'm thinking, like, we stuck, then we went back to the question, and then we meshed the R, and it makes sense in that sense.
So from A. EA. That means that B. So A is gonna be BB as well. Okay, that works. And then B.
Oh, it's gonna be a long,
Okay.
we got 4 hours, bro.
No. B has to point somehow to A. Should,
Yeah, with A.
well, that would make it impossible to get exactly 2 B's.
What do you mean? It still can.
Well,
This
you
this
leave-
sees the final
Well,
state.
you leave in a possibility to loop always B and A, and then B, and then end. For this, right?
Oh, there's no possibility to have it always B.
2 B's, yeah.
Gotcha.
So, but what I'm trying to say is, we need somehow to loop with B as many as we want. So I think that's what B is.
So that's okay. Let's think about this, right? Then we have A is B is going to be back to but A is B to B. Makes sense, I guess.
And then B,
Okay. Two B's. We always have to have it. So we continue A, B, B. Good. Then we have this one. It can be odd or even, doesn't matter. Okay. I like this one. I like this one.
because look, A,
Okay.
we got 3 A, right?
Boom.
And then we can have as many A's as we want.
Exactly.
But what about if we want no A's at all? We can just go straight up go. And then, but what if we want two straight up? Yeah, yeah, yeah. Yeah, it works.
Yeah.
I'll take a picture of it.
Yeah, well. My God, figure it out, type shit.
TypeScript. TypeScript.
Jag kan inte se, klart.
No, but to be professional.
Alright, let's do nothing here.
What's the time? I gotta eat.
You gotta eat?
Got 20 more minutes.
20 more minutes?
20 more minutes.
Okay, I feel like we can figure get something.
Okay. You take a picture of it, right?
Yeah, I did.
Okay.
That's what we're recording the news. Go quick. Remember the left? Yeah, we just copy.
We do remember we can just copy it.
Alright, let's just copy so we can make it quick.
It's left, right?
Yeah, left.
So left is, I'm gonna write the answer. Or this, the R. I use.
Yeah, go. Then here's your one notes. I feel like if we figure this out, it's gonna help us a lot. Making any NFAs or understanding grammar properly. Usually, oh, you already finished it. You can start, or you can start, you can start solving it while I'm writing it. You can start doing the initial thing.
CAAA.
Yeah. Alright, let's figure it out. Go home.
I'll probably eat it here. I brought food with myself. Do I have any?
Alright. So let's start always the initial.
Did I bring any, did I bring my thing? Oh yeah, I do have it.
You do.
Oh my God.
Okay. Alright, so A, B, B. So one thing is, how do we build the NFA?
Wait, what did you do here?
Line.
B, 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 okay.
Yeah.
Okay, I was confused. Sorry.
So one thing here, it's
Yes, so
we
we start,
B initial state B, I mean bridge state B, and then A. Hold on with that.
how do we do this?
At least now we don't have any, oh.
No, we don't have any, right?
We do. These two. A is well, A is B for the moment.
No, but this one is the same thing here. Well, we did the last time. What we did the last time was S and then BBS.
No, that wasn't it last time. That was the explanation we did in class.
Let me check again.
Look at here. Look at those two. That was this one. That was our linear anyway, so it's not left.
But yeah, that's, you see, you include two states in the options.
yeah, but-
we're not including any two states in the options. Like in one, option, you know what I'm saying?
There's only one state in each option.
Yes, so A, you messed up the A, right? It's A, B.
A, B? Okay, I
B.
thought I maybe did it wrong. Okay, so there's.
Okay, so it was wrong. Alright, yes, I was like, what the hell?
We got happens from again. These ones, I hate these ones now. There's two states.
Okay,
Alright, what the, okay, you figure this one out.
okay, let me try to figure this one out.
I'm gonna pack all my stuff.
So let's get A, right? Let's figure out A. A can be B as well for a second, which means B is pointing A. And then,
Let's actually kind of start. We can start with the other ones first. And now, wait, should we just start with C? And build up? What do you think?
yeah, I agree. But this
Two
one,
A's. Oh yeah, wait. Make a loop. Make a loop for A. CA.
so now we have A, B.
So we should have four A's. So there should be another state connecting to A. That bridge
Let
state.
me try to understand this.
I got you,
first.
so-
Let me try to understand this first, all right? What we are trying to do is end up to A
With two B's.
with one B,
Oh, there you go.
with two B's.
Yeah, that's right. I think we're just working the opposite way.
Yes, you're right.
So we'll start with C in a sense, and we just build BB. So do a bridge state, one bridge state. No, the other way. Because you're going back to S.
Oh, yeah. But how we get into C?
That would be from A and B. So first, bro,
This is so confusing.
okay, let me see here, 1 second. I'm thinking this, bro, right? You should keep it.
It's okay, do it. We can like know what you wrote and what I wrote.
No,
You cannot point, you think you're pointing B there, right?
no, just bridge state. I think I'm
Yeah, pointing B there.
Yes, that's what I'm thinking. But then I don't
But
understand
that's
the difference
that's
with right.
That's BBA, right? You going to A.
So it's supposed to be. How does this work, bro? What is going on?
I mean, I
I
don't think,
that S might be the final state, bro. Because what are we looking at right now is like this.
A, but how are you gonna point? What you pointing? You're pointing, what are you pointing to as?
DBA. I don't know what's going on. Bro, I'm cooked. I think it's just this.
Why?
I don't know. I think, or it might be a B. All I know is this. We know this. We know C is a lambda, and it has by itself a loop for A,
Okay.
right?
Yes, that's
Right. And then we know B. It starts.
but even that, can I try to imagine, sorry, but can I try to imagine how
We never build the NFA with the left linear glass, so we don't have to worry about this. I feel like we should go.
I know, it's just interesting.
I
Going
know it
to
is.
yeah, we should go eat food. So we just stop it,
Yeah, we stop.
call it a day.
Yeah.
Yeah,
But we're wasting time. We don't have enough time.
yeah, and then we're exhausted, so.
Exactly. And then plus this gonna be even in the test since we never built the left linear.
Yes, we're trying to work efficient here, all right?
Yes, sir.
But, yeah,
I'll
I'll
take a picture of it and
Yeah.
after the final, I'll
take
ask
the
the
whole picture,
professor.
yeah, take the whole.
Ask the professor what he thinks or how is it even possible. I think we got the other one right, the right linear one.
Right, yeah, that's what we think
We got it right.
we're probably not even getting one because we're just trying to build it by ourselves.
All right, I'm gonna log you out of the computer.
Oh, yeah, thank you. And I'll finish this.
Right, let me clear the
All right, guys, I'll see you. Peace out. You just leave, right? Oh, you gotta stop recording. Bro, we have 4 hours.
Yeah, I know it's cooked.
Okay, we are a little bit behind with what we wanted to do. End meeting or yeah, end meeting.
All right,
How do you stop recording?
we
It's like-
stop recording. Go to the recording.
I'm trying to like. Oh, okay, it's from here.
Stop recording.
All right.
All right.